Hi friends, today let us discuss some basic terminologies of automata theory. Alphabet represented by summation. Alphabet is a finite non-empty set of symbols or characters represented by summation. For example, this alphabet is finite consisting of two alphabets 0 and 1. So, this alphabet is a binary alphabet. This alphabet consists of two characters A and B. This alphabet consists of set of all lowercase English alphabets. This alphabet consists of all different types of opening and closing parentheses. The last alphabet consists of some of the special characters like hash, dollar, star, at, ampersand, etc. String. A string is a finite sequence, possibly empty, of symbols drawn from some alphabet summation. For example, if we consider alphabet 01 of binary alphabets, the possible strings of this alphabet are possibly empty. So, possibly empty is represented by first string as epsilon, second string consisting of a single 0 or a single 1 or two zeros 0 1 1 0 1 1 0 0 0 0 0 1 so on up to 1 1 1, then 4 zeros and so on. So, the shortest string is the empty string represented by epsilon, and summation star is a Kleene Star operator which represents the set of all possible strings over an alphabet summation. So, let us see some of the functions on strings. So, the first function on string is length, which represents the length of the string, yes, that is the number of characters present in that particular string. For example, epsilon represents empty string, so the length of the string is equals to 0. So, consider the next example. In this string 1, 2, 3, 4, 5, 6, 7 numbers. So, the total length of this string is equals to 7. Next comes the occurrence of C in S, represented by hash C of S, which defines the number of times C occurs in S. For example, number of times A occurs in this particular string is equals to 1, 2, 3, 4. So, after seeing the length and occurrence, let us see one more function on strings, that is concatenation. So, what is concatenation? Concatenation of two strings S and T is the string formed by appending T to S, represented as S appending T, or just normally we can write S T. Let us take one example. If X is equals to good and Y is equals to buy, then X Y is equals to good buy. And if we concatenate YX, then the string will be buy good. Note that the length of this XY will be equivalent to the length of X plus length of y, that is 4 plus 3 is equals to 7. Remember, epsilon is the identity for concatenation of strings. That is, for all x, if x is concatenated with epsilon is equivalent to epsilon concatenated with x is equals to x, and concatenation is associative. That is, for all STW, STW is equals to S of TW. So, the next function on strings is replication. For every string W and each natural number k, the string W raised to k is W raised to 0, that is k is equals to 0, string length is 0. This is possible when the string is equals to epsilon. Next, W raised to k plus 1 is equals to W raised to k plus concatenated with W. For example, a raised to 3, that is a is replicated 3 times. So, the possible string is a. By is repeated 2 times. So, the possible string obtained is bye. In this string, a is replicated 0 times, b is replicated 3 times. Hence, the string obtained is b. And in the last string, b is replicated 2 times, y is replicated 2 times, and e is replicated 2 times. Hence, the string obtained is bb, yy, ee. Next is reversing a string. For each string W, the reverse of W, that is W raised to R, is defined as if the length of W is equals to 0, then W is equals to W raised to R, that is nothing but epsilon. If W is equals to 1, then W raised to R is equals to W, because the length of the string is 1. For example, if W is equals to A, then W raised to R is also equivalent to A. But if length of W is greater than 1, then for some A belongs to summation, for some U belongs to summation star, then the string W is equals to UA, and W raised to R is defined as A U raised to R. For example, W is equals to A1, A2, A3, so on up to AN, then W raised to R is AN, so on up to A2, A1. If W is equals to 1, 0, 1, 0, then W raised to R is 0, 1, 0, 1. So, let us see a theorem on concatenation and reverse of two strings. If W and X are strings, then W concatenated with X whole raised to R is equals to, reverse of it will be X raised to R, W raised to R. For example, if W is name and X is tag, then name tag whole raised to R is equals to tag raised to R, name raised to R. So, reverse of tag is GAT and reverse of name is EMAN. The string obtained after concatenation and reversal is GAT-MAN. And this theorem is, let's see some relations on strings. First relation, substring. String S is a substring of string T if S occurs continuously in T. For example, consider T is equals to 3A's, 3B's followed by 3A's. Check. Is S1 substring of this string? What is S1? S1 is equals to A. We have A or here A. So hence S1 is a substring of string T. Take one more example. S2. S2 consisting of 6 A's. Is this string present in this string? No, because all the 6 A's are not contiguous. They have 3 B's in between. Hence, S2 is not a substring of string T. So, every string is a substring of itself. So, this string T is a substring of itself, and epsilon is a substring of every string. So, by default, the first substring of this string will be epsilon. So, next relationship, that is proper substring. S is a proper substring of T if and only if S is a substring of T and S is not equal to T. For example, suppose T is AA, BB, CC. Then possible substrings of this string are by default string epsilon, A, 2A's, 2A followed by AB, 2B's, 2C's, a single B, a single C, AA, BB, CC, that is T itself, are all the possible substrings of T. Whereas the proper substring is AA, BB, CC, because this AA is not equal to string T, BB is not equal to string T, CC is not equal to string T. Hence, these three strings are proper substrings of T. Take one more example, AA, BB, CC. Is this string a substring of T? Yes. But is it a proper substring of T? No. Why? Because it violates the definition of proper substring. What it states? S must not be equal to T. Whereas here T and S both are same. Hence, this string is not a proper substring. Prefix relations. S is a prefix of T if and only if for some x belongs to summation star T is equals to Sx, where S is the prefix of x. And S is a proper prefix. When do we say it is proper prefix of T? If and only if S is a prefix of T and S is not equal to T. Let us take some examples of both prefix and proper prefix. Say suppose this is the string ABBA. So prefixes of ABBA are epsilon, A, AB, ABB, ABBA. Proper prefix of ABBA are epsilon, A, AB, ABB, whereas it does not include ABBA, because if we include ABBA as a proper prefix, then at that time S will be equal to T, and it violates the rule of proper prefix. So these are the four possible proper prefix of the string ABBA. Note that every string is a prefix of itself and epsilon is a prefix of every string. Similarly, let us discuss suffix relations. S is a suffix of T if and only if for some x belongs to summation star T is equals to x S. So, S is the suffix of x. And what is the proper suffix? It is proper suffix if S is not equal to T. Let us take an example. Suffix of ABBA. What are the possible suffix of ABBA? Epsilon, A, BA, BBA and ABBA. Proper suffix are epsilon, A, BA, BBA. Can I include ABBA as a proper suffix? No. Why? Because at that time S will be equal to T. Note that every string is a suffix of itself and epsilon is a suffix of every string. Till now, we discussed the definitions of alphabet, string, functions on strings and relations on strings. Let us learn definition of a language. A language is a finite or infinite set of strings over a finite alphabet summation. For example, if the summation is AB, let us see some of the languages on this alphabet AB. Empty language, that is a language consisting of no strings, is represented by null. Language containing only the empty string is represented by epsilon. Language consisting of two strings, either A or B. And the last language consists of strings including epsilon, 1A, 2A's, 3A's, 4A's, 5A's. That is at most 5 A's in this particular language. Then what is summation star? As we discussed, summation star is defined as the set of all possible strings that can be formed from the alphabet summation. So, summation star is a language which contains an infinite number of strings. Then summation star is countably infinite. For example, let us consider the same alphabet AB. Then the possible strings in summation star are epsilon, A, B, AA, AB, BA, BB, AAB, AAA and so on. Hence, this language is countably infinite. The language is defined similar to our setter notation, that is L language is equals to all possible strings W which belongs to summation star, where next is a description of W. This description of W can take many forms, but it must be precise and the notation can vary. There are two ways to define a language. One is the recognizer, which enumerates or lists the elements of the language. or the language can be a generator which decides whether a candidate string is in the language and returns true if it is in and false if it isn't. Let us see some examples of language definition. Language L consists of all possible strings X which belongs to alphabet AB with the description or the condition that all A's will precede all B's. For example, possible strings of this language are AB whole star, so it is epsilon, first string will be epsilon, A, two A's, two B's, A's followed by B's, A's, all A's are preceded by all B's, all A's are preceded by all B's. So all these strings are present in the language. Consider some more strings ABA, BA and ABC. Do they belong to this language? No. Why? This A is preceded by B, but this A is not preceded by B. Hence, this string does not belong to this particular language. Similarly, BA, this A is not preceded by B. So, this string does not belong to this particular language. Next, ABC. This string does not belong to this particular language because C is not present in this particular alphabet. Only two symbols present in this particular alphabet are AB, whereas we have included C. Hence, this string ABC does not belong to this particular language. Take one more example. L is equals to all possible strings X such that for some Y belonging to AB whole star, X is equals to YA. That is A. X is YA. Y can be epsilon followed by A. So, first string is A. Y is A and A concatenated. So, I will get AA. Next, Y is a single B concatenated with the A. So, BA belongs to this particular language. Then AAABB is your Y string concatenated with A. So, this is X which belongs to your language L. Similarly, this AABBB is your Y concatenated with A. This is your X which belongs to L. Let us see some strings which do not belong to this particular language. ABAB. So, if I consider ABA as your Y, it must be concatenated with A, whereas here it is B. Similarly, here it is B. So, it is not accepted. Similarly, here it is C. So, C does not belong to your alphabet. So, this string also is not accepted by this particular language. So, if I want to know the description of this language in English, then I can make a statement that this language consists of strings of all possible strings over alphabet AB ending with A. So, if you can see here, ending with A strings are accepted, whereas not ending with A strings are rejected. So, in this way, we can write English description for all the languages. Let's see some more examples of language definitions. Over summation AB. This language represents all possible strings whose length is 5 over alphabet AB. This language consists of all possible strings over summation AB where all the strings W begins with B. This language consists of all the strings over summation AB where the number of B's present in these strings must be equal to 2. In this language, the language consists of all possible strings W over AB where each A is followed by exactly 2 B's. This language consists of all the strings W which does not begin with A. Here all the strings those begins with B, and in this language all the strings which do not begin with A. Enumeration is to list all strings in a language set either by arbitrary order or by putting them in lexicographic order, wherein all the shortest will come first, and if the strings are of the same length then they are sorted in dictionary order. Next definition supposed to discuss is cardinality of a language. Cardinality of a language is the number of strings in that particular language. The smallest language over any summation is null with cardinality 0, and the largest is summation star. Then, is it true? We are supposed to discuss how big it is. Can a language be uncountable? These are some questions to be answered over the language summation. Let us discuss a theorem on countably infinite. If summation is not equal to null, then summation star is countably infinite. The elements of summation star can be lexicographically enumerated by following procedure. First, enumerate all the strings of length 0, then length 1, then length 2, and so forth. If the length of the two strings is same, then enumerate them in the dictionary order. This enumeration is infinite since there is no longest string in summation star. Since there exists an infinite enumeration of summation star, it is countably infinite. Let us discuss one more theorem on how many languages are there. After knowing the definition of language, how the language is written, let us discuss functions on languages. Languages are closed under union, intersection, complement, difference, concatenation, and Kleene Star. Let us discuss all these functions in detail. Summation is AB and two languages defined over summation AB. L1 consisting of all the strings with an even number of A's. That is, it may have any number of B's, but the number of A's must be even. L2 language consisting of strings with no B's. Strings with no B's, it means all possible strings of A's. Includes epsilon, 1A, 2A, 3A, so on up to any number of A's. On applying the first function, that is union, on these two languages L1 union L2, we get all possible strings with even number of A's and all strings with A's plus strings that contain B's. On applying intersection for L1 and L2, L1 contains even A's, L2 contains all A's. The intersection of this contains even number of A's. L2 minus L1. L2 contains all A's minus L1 contains even A's. Then the possible strings in this language will be odd number of A's. And complement of L2 minus L1 will be all the strings with at least one B. Here it is no B's, so its complement will be strings with at least one B union strings with even number of A's. So this is how we can apply the functions on the languages. Concatenation of two languages. If L1 and L2 are languages over summation, then L1, L2 consists of all possible strings of W such that some S belongs to L1, some T belongs to L2 and W is equals to S followed by T. For example, if L1 contains two strings cat and dog, L2 contains two strings apple and pear, then concatenation of L1, L2 gives cat, apple, cat, pear, dog, apple, dog, pear. And if we concatenate L2, L1, we get apple, cat, apple, dog, pear, cat, pear, dog. This is how we go for concatenating two languages over alphabet summation. So some properties on concatenation. Epsilon is the identity for concatenation, that is L language L concatenated with epsilon is equals to epsilon concatenated with L is equals to L, and null is a 0 for concatenation, that is L concatenated with null is equals to null. Kleene Star. L star is the language consisting of 0 or more concatenations of strings from L, that is all possible strings of L. For example, if L contains three strings dog, cat and fish, then L star is all possible combinations of this L, that is first epsilon, dog, cat, fish, dog, 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 cat, dog, fish, then fish, cat, fish, fish, dog, dog, fish, cat and so on. Plus operator. L plus is a language consisting of one or more concatenations of strings from L. How it is different from star? L plus is L concatenated with L star, or L plus can also be defined as L star minus epsilon if and only if epsilon belongs to L. And last, reverse of a language. Reverse of a language L raised to R is defined as L raised to R is all possible strings W which belongs to summation star where W is x raised to R for some x belonging to this particular language.